Good morning, everybody. All of us are going through a very tough phases of life. The virus is spreading everywhere, so it is better to stay at home, stay cautious. As our regular classes are off, so I have taken the online version of teaching. I am making short homemade videos of the lecture materials, but as this is a homemade video with very limited logistic support, I hope my voice is audible and the writings on the whiteboard is visible to you. In semester 4, we are discussing about quantum chemistry, that means application of quantum mechanics in chemical system, specifically to atoms and molecules. Already we have covered conservation of angular momentum and hydrogen atom problem. I have already uploaded the necessary lecture materials on hydrogen atom problems. We have got the total hydrogenic functions from the three parts, radial and the two angular parts, theta and phi. Now our main emphasis is to extend our previous concept to multi-electron system. That means we will try to apply Schrodinger equation to multi-electron system. But before going to multi-electron system, I will go to a little bit about the energy of hydrogen atom system. From the radial part of the hydrogenic wave function, we will get the energy expression, and we know it's a very famous expression is minus mg square e to the power 4 by 8. If we write in SI unit, then it 8 epsilon 0 square n square h square. This epsilon 0 terms comes from the potential energy, because if we write the potential energy of hydrogen atom systems in SI unit, it becomes Z square by 4 pi epsilon 0 into R. This epsilon 0 is the vacuum permittivity. Now this energy expression can be written in various forms. We can write this expression as minus E square by 8 pi square n square and a0. This a0, obviously there will be an epsilon 0 term, 8 pi square n square a0 epsilon 0. This a0 is the Bohr atomic radius, or we may write it by putting all the fundamental constants. It will now then become minus 13.6 by n square in electron volt unit. So what is evident from this equation is that energy of the hydrogen atom system is negative. First of all, it's negative. That means it indicates bound system, or it indicates there is a attractive potential between the nucleus and the electron. Another important part is that this hydrogen atom energy is proportional to 1 by n square, where n is the principal quantum number and these are positive integer values. So as the n value increases, en value decreases. So in the limit n tends to infinity, en tends to 0. Now why this limit, from where this limit comes? Actually it comes from the well behavedness of radial part. This RR part goes to 0 as R tends to infinity. So hydrogen atom energy as this expression is basically reciprocals of the square of the principal quantum number. Now we want to make one interesting proposition regarding the energy of hydrogen atom. If one try to calculate the average potential energy of the system, then what will be the value? So our intention is to calculate the average potential energy of hydrogen atom system. Now for simplicity, we will calculate the average energy of one state, because already we know there are hydrogenic wave functions for the one state. So if one have to calculate the potential energy for the one state, how one can calculate the average value? Because we already know that average value of any property A, where A is a physical observable, can be written like that: integration all space psi star A operator psi d tau by integration psi star psi d tau. Now if our wave function is well behaved and is normalized, if normalized, then it is equal to 1. If the wave function is already normalized, then the average property will be like psi star A operator psi d tau. Following this procedure, one can calculate the potential energy, or rather average of potential energy for hydrogenic ground state. Now here the operator is potential energy operator, so obviously this potential energy operator is basically minus E square by 4 pi epsilon 0 r in SI system, and the hydrogenic one state we know is 1 by pi A0 cube to the power half into e to the power minus r by A0. Now as hydrogen system is a spherical one, so we have to calculate the average property taking the spherical coordinate. Now this d tau, this volume element which is required in the integration part, is basically r square dr sin theta d theta d phi in spherical system. But as potential energy is only a function of distance, it doesn't depend on the angular part. So for here this part will be, we have to fully integrate the angular part. That means sin theta d theta up to integrate up to 0 to pi and d phi up to 0 to 2 pi. This will give a value of 2. This will give a value of 2 pi. Multiplying we get 4 pi r square dr. So while evaluating the average of the potential energy, we can replace d tau by 4 pi r square dr. So now we proceed to calculate the average value. So this is psi star A operator psi d tau, and now d tau is 4 pi r square. This 4 pi will come out of the integration. There is no meaning of psi 1 star because there is no imaginary part in the hydrogenic function, basically in the ground state. So it becomes psi 1 square. So 1 by pi A0 cube will come out of the integration, and this E square by 4 pi epsilon 0 term minus E square by 4 epsilon 0 terms, this will also come out of the integration. So minus E square by 4 pi epsilon 0, and within integration there will be this integration from 0 to infinity. It will be E square, that means e to the power minus 2r by a0. Here is 1 by r, and we get another r square here, so it becomes r dr. So now we will proceed to solve the integration. So basically 4 pi will nullify each other, and there will be minus square by pi a0 cube epsilon 0, and this is basically x to the power n into the power minus ax dx. So the integration will be n factorial, that means 1 factorial, and 2 by a0, here is basically a to the power n plus 1, that means 2. Ultimately we get an expression like is minus square by 4 pi epsilon 0 a0. So this is the average potential energy of the hydrogen atom ground state. Now if we compare the value, this value, with the total energy of the hydrogen system, then we will find that this is actually, this potential energy is actually twice of the average of total energy. This is the total energy. Already you know the total energy of the hydrogen system. So potential energy average is twice of the total energy. Actually we know that for any system, total energy average, total energy is a summation of kinetic energy and potential energy. So this is also potential energy plus kinetic energy. And already we have proved that this potential energy is twice of the total energy. So we can replace this potential energy by twice E of average. Then it's become kinetic energy average becomes equal to minus of total energy. So this is an interesting aspect. For hydrogen atom ground state, we got this potential energy average is twice of total energy average, and this is popularly known as Virial theorem. This is popularly named as this equation, potential energy is twice that of the total energy, is known as Virial theorem in quantum chemistry.